Everyone, welcome to lesson 5 for trigonometry. Today's lesson involves stage 5.1 and 5.2. So today we are looking at angles of elevation and depression. So that's what you need to be able to do, identify angles of elevation and depression using diagrams. So first of all, what do we mean by angles of elevation? So the person here, if he's looking up at people in a balloon, the angle of depression is the angle this way. So from the horizontal line up. So elevation is when we look up. And if we had the people in the balloon looking down, that's the angle of depression. From our work in stage 4 geometry, we know that if this is 10 degrees, then this will be 10 degrees as well. These angles are equal. The reason is they're alternate, and alternate angles are, or Z angles. This angle here are equal if we have parallel lines. And because this is the horizontal, this is what we call the horizon, or parallel to it. These are both horizontal. The angle of depression will equal the angle of elevation. So you can see here, if this one's 37, this one's 37, because these two lines are parallel. So elevation goes up, depression goes down. So now we have questions like this one. Find the height of the tree. We don't need that 20 there. Find the height of the tree, which is interval BC. So from here to here. So the height of the tree, we can use H for height. If the person is standing 5 meters from the tree, where the angle of elevation is 20 degrees. So the person is standing here. The question clearly states that the angle of elevation is from the ground. So it's measured from here. So the angle is 20 degrees in here, the angle of elevation. A harder problem might actually include the height of the person. This one doesn't. So now we're finding the height. We know this is 5, so this distance here is 5. So we know the angle opposite the height is 20, so this is our opposite side. And we know the side adjacent to the angle is 5, so we know opposite and adjacent, so we can use the tan ratio. So we're using opposite and adjacent, so we're going to use tan. So tan 20 degrees is opposite over adjacent. Tan 20 equals h over 5 times both sides by 5 and do the calculation, and we get 1.8 meters. So it's good to round to 1.8 meters, or 1 decimal place, unless the question says otherwise. Finish off with a sentence answer because we have a sentence question. Just a little note here as well. This symbol here means therefore. So this is our working, and this is our conclusion. So for angles of elevation and depression, you'll get a variety of questions. This one is pretty common. The difference for level 2, so we make it a little bit harder. By not providing the diagram. So just a reminder, elevation is where we go up. Depression is where we measure the angle down. And we have problems like this one, like this example, where we don't start with a diagram. You actually have to draw the diagram. So from a point P on the ground, so have a starting point. This one's called P. Sometimes you might just call it S for start, but it clearly says point P. The angle of elevation, so elevation, we think up straight away, up from the horizontal. Is 50 degrees. So this angle here is 50. If P is 8 meters from the tree, so 8 is here and the tree is here, find the height of the tree. So very similar to the previous problem, but we have to draw the diagram. So 50 is here. Remember, angle of elevation is up. Opposite, adjacent. So we're using tan again, which is quite common for elevation and depression problems. So tan 50 equals h over 8. Multiply both sides by 8. We get 9.5 meters. So the height of the tree is 9.5 meters. We also need to look at bearings. So people in ships and planes use bearings quite frequently. North is straight up. So this is a compass rose, and we normally say that north is up. That's one of our conventions. As a 3-figure bearing, we say 0, 0, 0. So we use 3 figures. So north, east, south, and west. You might use something like news or never eat soggy Weet-Bix to help you remember. So never eat soggy Weet-Bix might help you remember it. East is 090. South is 180 degrees. West is 270 degrees. And we have 45 degrees in between. So 90 plus 45 is 135 to get northeast, southeast, southwest, and northwest. You look at your iPhone if you have one, you might be able to get this as well to see where you're going. So just a few examples here. We've measured the angle around from north. This one goes around 60 degrees. The bearing is 060. Or we could say north 60 east as well. So bearing of 240, so remember 90 is here for east, 180 is straight down for south, and this one's going a little bit more than 180. Okay, so it's going 240 degrees from north, so the bearing is 240 degrees. The other way that we could say this is south, 60 degrees, west. This angle here would be 60, which is 240 take 180. If we go a bit further, this angle here is 330 degrees. So the bearing is 330. The angle in here would be 30 degrees. So 360 take 30. So we could say that it's north 30 degrees west. There's a few ways that we can do bearings. This problem, a boat sails 20 kilometers on a bearing of 0.45 towards a lighthouse. So this distance here is 20 kilometers. Most of our problems will involve kilometers. Harder problems might include nautical miles. For this question, we want to find how far east did the boat travel. So our compass rose looks like that. The starting point is actually down here. We want to find out how far east. East is this direction. So we make a right angle triangle and use trigonometry. Use SOHCAHTOA. So the distance east is this way. So this diagram puts the triangle here, which is fine. Either triangle will get the correct answer. So distance east, so that's our variable, we'll call it E. Starting point is here. And because the bearing is 0.45, means it goes around 45 degrees this way. So sine 45 is the opposite over hypotenuse. And we multiply both sides by 20. So E is 20 sine 45, which is 14.1 kilometers. Little note down here that when we start talking about surds, we can leave our answers as exact values and surds. For now, I'm happy to leave it with 1 decimal point, 1 decimal place. Okay, that's the end of today's lesson. Do some practice questions and let me know if you need some help.